Pre-algebra lesson 87, properties of algebra. So this is a very big lesson, and it's got some pretty simple properties that will follow us through the rest of algebra, and well, I mean the rest of math, period. These properties are just as fundamental to math as, you know, saying the shortest distance between 2 points is a straight line. But they're hard to understand because math books love explaining them in math speak, which means instead of using numbers, I'm going to use letters, and then the letters get confusing because we're just learning algebra, we're just learning how to do math with letters, and this doesn't make any sense, and why is there A, B, and C, and what does this mean? I don't get it, right? So we're going to go over these properties, and I'll explain them logically, based on their logical roots, and how they translate to something that you guys are familiar with, and something that I'm familiar with, and something that I like dearly. I love dogs, right? I hope you like dogs too. Pets are great. I think living in America, we're blessed to have the luxury of pets. It's a cool thing not all countries have. And we're going to use dogs to explain the basic properties, and then once we learn those basic properties, I'll explain these, the first two, the commutative and the associative, using good old numbers. So let's start with the reflexive property. The reflexive property says A is equal to A. Now, what that means logically is that a dog is a dog. Actually, you know, wait, I've got a great idea. Maybe I should do this with pictures. There. Oh, wait, didn't work. Can't see it. Hold on. How about now? Nope. Still no dog there. Weird. How about now? What? Oh, nope. That was wrong. Okay, I figured it out. Haha! Dog. Whoops. Okay. Everyone should be able to see the dog now. Alright, so we're talking about reflexive property. Reflexive property, logically, would be saying, like, this dog is a dog. See? There's the dog. He's a dog, definitely, right? The reflexive property is quite simply saying that something is, in fact, itself, or that idea is, in fact, that idea. So, for example, for me to say that this dog is a dog, that would be an example of the reflexive property. It's very basic. It's just like saying the number 5 is equal to 5. Right? Now, let's go over to the symmetric property. Let me do a quick check, make sure this camera's in the right spot. Yep, okay. The symmetric property, okay? So the symmetric property puts another piece of logic or another idea into the scenario. So let's say this dog is the only dog in the room. Then I could say the only dog in the room is, or sorry, no, whoops, that was the wrong sentence. Not the only dog. Let's say this dog is the only animal in the room. There we go, that makes more sense. This dog is the only animal in the room. Then you could also say that the only animal in the room is a dog, right? So that's the symmetric property. So saying A is equal to B is like saying this dog equals only animal in the room. Then only animal in the room is this dog. Great. Now let's go into the transitive property. This is where things get exciting, right? Now let's say this dog is the only animal in the room, right? And the only animal in the room is named Doug. Then I can say that this dog is named Doug. All right, does everyone get that? All right, so if this dog is the only animal in the room and the only animal in the room is named Doug, then I can say that this dog is Doug. Right? So that's transitive property. It's where we transfer one fact from two equal items onto the other equal item. So that's how we say mathematically if A equals B, B equals C, then A is also equal to C. So those are the three basic math properties of this is a dog, this dog is the only animal in the room, and if this dog is the only animal in the room and the only animal in the room is named Doug, this dog's name is Doug. Great. Thanks for joining us, Doug. Goodbye, Doug. So kind of him to help us out. All right, now let's go to the commutative properties and the associative properties. Now, the commutative properties, what they say, and this is actually something that I've kind of been doing with you guys, but I haven't really mentioned it, and you'll see me do it again, and you're like, oh, he's been doing that forever. Yeah, I have. The commutative properties say that if I'm only adding or only multiplying, I can add or multiply those numbers in whatever order I want. And that's something that we saw a few lessons ago when we were doing algebraic addition. We found with algebraic addition we can add in whatever order we want. And the same is true for multiplication. So let's test it. All right, so let's say I've got 1 plus 2 plus 3. Well, that's going to equal 6. And then I could do 2 plus 3 plus 1. Change the order. That's still 6. Let me do 1 plus 3 plus 2 Well, that's 4. That's still 6. Same thing goes with multiplication, right? So let's say I wanted to multiply. We'll do 1, 3. No, yeah, 1, 3, and 4. So let's say I do 1 times 3 times 4. Well, that's going to equal 3 times 4. That's going to be 12. And if I do 4 times 3 times 1, oh, that's 12 times 1. That's still going to equal 12. Wow, what if I put the 1 in the middle? If I do 4 times 1 times 3? Well, 4 times 1 is 4 times 3 is still 12. Great, so we can see it doesn't matter what order we put them in. Algebraically, we get the same answer either way. So the way we do that is when we're solving problems, like for example, if I have 5 plus 25 plus 20 plus 4, oftentimes what you'll see me do is I'll do things like this. Okay, let's see here. I'll do 5 and 25. Oh, that's 30. Okay, and then 30 plus 20, that's 50. And then 50 plus, oh, hey, that's 54, right? This is me using the commutative property, right? In so many ways. And I'm doing it without doing all this extra parenthesis work, right? So if you logically understand the property, you can do it using the same methods I've already been using. I could do the same problem in a different order too. So let's reset the problem. 5 plus 25 plus 20 plus 4. Oops, that's not a 4, that's a 2. That's a 4. Okay. So I could have gone, hey, let's just add these two. We'll get the hard part out of the way. That's 25 plus 20. Oh yeah, that's 45. From there I can add, hey, that's 50. And hey, there we go. That's 54. Great. So you see how that works? It's something that we can do in all of our problems. So oftentimes in your homework, you'll see problems that say use commutative and associative properties to simplify addition or subtraction problems. Okay? Yeah. That's all I've got for you guys today. If you have any questions, let me know on the school website, and I'll see you in class.